So we're going to start with our revision. We still continuing on the topic of electromagnetism, but today we're going to cover the last subtopic, which regarding the transformer and the use of transformer in the transmission of electricity. So let's review what is the transformer. So transformer is basically a device that can step up or step down voltage or potential difference, doesn't matter, of an alternating current. This is very important because transformer only works when there is alternating current. If you use direct current, then nothing changes, even it doesn't flow the current at the secondary coil. So again, it can step up or step down potential difference or voltage of an alternating current. All the keywords must be included. So if the question asks what is step up transformer, you just say that a device that can increase voltage. You don't need to repeat the word step up of an alternating current, or step down, you can just say decrease voltage or reduce voltage of an alternating current. So basically, that's kind of a specific definition, but usually the question just asks us about what is transformer. That's a very common question. Okay, number two, name two types of transformer below. Again, if you see the secondary coil has a large number of turns compared to the primary coil, that means this is step up transformer. Whereas the B, you can see that the secondary coil is less than the primary coil. That is what we call step down transformer. Step down transformer. Okay, number three, diagram shows a step up transformer. Again, why it's called step up? Because the secondary coil has a larger number of turns compared to the primary coil. How we know which one is primary, which one is secondary? Primary always connected to the power supply, which is the AC current, whereas secondary must be connected to load, such as menthol, bulb, motor, or whatever. Okay, explain how this transformer can be used to increase the output voltage. So we can treat this question as a 4 marks question. So we have the 5 points to write. Start. Alternating current flow in the primary coil. So this is very basic. You must start with primary coil. What current? Alternating current flow in the primary coil. Next, changing magnetic field flux occurs at primary coil. Concept here, soft iron core links the magnetic field flux to the secondary coil. Or you can say that cut the magnetic field flux, cut the secondary coil. Also for the concept here, but I like the soft iron core concept here. Conclusion. Induced current flow at the primary or in the secondary coil. Or we can say that induced EMF produced at secondary coil or induced current flow in the secondary coil. So the result, higher output voltage due to higher number of turns. turns of coil. This is what we call Faraday's law. Faraday's law states that the magnitude of induced current is directly proportional to the rate of cutting magnetic field plus rate of change of magnetic field plus. So basically, this is the 5 points, basic points for explaining the working principle of transformer. But in this case, we specify the transformer to be step-up transformer. So if you have a step-up transformer, what's going to change is we have to change the result over here. Either higher or lower, depends on the type of transformer. So if the question just asks about a general transformer, then the result is going to be induced current flow in the secondary coil. The conclusion you have to change to induced EMF produced at secondary coil. So that's only the difference that you need to do. But basically, we don't really need the conclusion or result. We can just make it into one sentence, but we must make sure that we have a backup plan in case one of the points are failed to reward us 1 point in the exam. So it's very, very good practice to write more than 4 points. Okay, so let's move on to number 4. Diagram shows a step-down transformer and two identical bulb P and Q. Okay, compare the brightness of P and Q. So we have what kind of transformer over here? This symbol is actually a transformer. So what kind of transformer is step-down transformer? How I know that? The primary coil over here is connected to the power supply, whereas the secondary coil is connected to the load or the bulb. So the secondary coil is less than the primary coil, the number of turns. So thus we call it step-down transformer. So what happened to the brightness? So we should observe that the Q has a lower brightness than P. Okay. Number 5, diagram show a simple transformer about light up with normal brightness. What is meant by normal brightness? The supply voltage equal to the label voltage in power rating. Okay, so if the power rating is 240 volts, 1000 watts, then if the supply is 240 volts, then we call it normal brightness. But in this case, since the bulb is light up with normal brightness, that means and we see that the number of turns of both primary and secondary coil are the same, because primary coil over here is connected to the power supply over here, the secondary coil connected to the load, which is bulb. They both have the same number of turns. That means this power rating over here is also 3 volts, but we don't know the power, but we know the requirement, the voltage requirement. So explain what happens if the AC input is replaced by 3-volt battery. So basically we're going to change the type of current here from AC to DC, direct current. What happened? So I already explained at the beginning of the video. If we use DC current in transformer, there will no induced current flow at the secondary coil. So we can say that direct current will not produce changes in magnetic field flux. Thus, no induced current flow in secondary coil. The bulb will not light up. So this is basically paper 2 structure question. It shouldn't be the essay question because the explanation is very simple. At least you need 2 points here. You don't need to write more than 2 points because it's probably a structure question. If it's an essay question, it's probably going to be longer. You need at least 4 points or you have to write 5 points to be safe. Okay, so that is the reason why the DC current is not working for transformer, because the magnetic field flux is constant, so that there is no changes to the magnetic field flux, so the induced current will not produce. So when does the induced current will flow or will produce, or induced EMF will produce? Only when there is changes of magnetic field flux through cutting of the magnetic field flux or movement, relative motion. Okay, so we already learned that before. Number 6, which is a functional step-down transformer. So it says step-down, so we must compare the number of turns first. This is the secondary coil. And then this is all the primary coil, because all connected to the power supply. So let's compare primary to secondary. This is step up, so this is not the answer. This is also step up, so this is step down. This is also step down. Now let's compare the type of power supply. This is use AC, so it's working. This is DC, so not working. So the answer is C. Okay. So let's move on to the calculation part of the transformer. So number 1, diagram shows the structure of an ideal transformer. What is meant by ideal? Efficiency is 100%. So we don't have power loss. What is the potential difference across the bar here? So what is the VS, the secondary voltage? So this is the primary, 240 volt. So this is number of turns. So we can use a ratio here. NS and P, VS, BP. So this is basically the ratio. How much from 80 to 20? 40, 4 times. So that's mean 240 must be reduced 4 times as well. This is gonna be 60 volt. So let's do the calculation to check if our answer is correct. 20 over 80 equal to VS over 240. So VS is actually, we can cancel this is just 1 over 4. 1 over 4 times 240. Again, 240 divided by 4, which already predict that before we do the calculation, 60 volt. So our answer is correct. So that's basically transformer. You just use the ratio. You don't need to think hard about it. You just see if the turns is 80 and the secondary turn is 20, how much is decreased or increased. In this case, it decreased by 4 times. That means the voltage also gonna decrease 4 times. So we don't need very complicated calculation here. It's just very common sense formula. Okay, number 2, a transformer with primary and secondary coil 50 and 250. So this is step up. Respectively, supplied 6 volt of alternating voltage. So supply means that output or secondary. Calculate the output voltage again. This is not correct. The question. You can say that. Yeah, you can say this being supplied by 6 volts of alternating current, then it's gonna be input. So sorry for the confusion, because supply here usually means that the transformer is gonna supply us how much voltage, the output voltage. But in this case, the question itself asks us to calculate the output voltage. So that means the 6 volt given here is must be input voltage. Means that transformer being supplied by 6 volt voltage, not supplied us the 6 volt voltage. So again, we use the ratio formula. So basically, it doesn't matter if you want to put MP first or NS later. It doesn't matter because it's just ratio. You just need to see the difference, the how much it decreased or how much it increased. In this case, 50 to 250 is basically 5 times. 50 times 5 is 250. That means the 6 volt gonna increase 5 times as well, become 30 volt. So let's check with our calculation. Vs is over 6. So Vs is actually 25 divided by 5 is 5. So 5 times 6, 30 volts. Because 6 is going to be here. So our answer is correct with our prediction. So let's move on to number 3. A laptop needs voltage supply of 6 volts. So this must be output. Connected to 240, this is input. If the transformer inside the adapter has 20 turns of secondary coil, calculate the number of turns of primary coil. Again, we just use the ratio here. How much 240 to become 6? It must be divided by 40, I guess. Yes, this must be divided by 40. That means 20 turns secondary must be increases 40 times. Because primary should be larger number than secondary. This is step down transformer. So 20 turns times 40 become 800. So let's check if our answer is correct. Ns over Np equal to Vs over Vp. So Ns here is 20 turn, Np unknown, Vs is 6.0, Vp is 240. So 6.0 is 1 over 40. So 40, MP over here, 40 over here. So MP equal to 20 times 40, which is 800 turns. Yes, our answer is correct. We just use ratio here. Number 4, an ideal transformer transferred 500 watt power through secondary coil with output voltage 1000 volts. So this secondary Vs. Calculate current produces at secondary coil. Again, this is ideal, so 100% efficiency. So the power 500 watt power must be same for primary and secondary coil. So the input must be the same as P output. V input I input equal to V output I output. So that's the formula for power. It asks us to calculate the current for secondary coil. So IO or IS doesn't matter here. VI II divided by V for V output. V input is again VI overall, we can just replace it with P 500. V output is 1000. So I output is 500. 5 over 10, 1 over 2, 0.5 ampere. Okay, our answer is correct. So why I do this, like doesn't put the individual values in it, because we know that VI is overall a power, a value for power, so it's already given as the power, so it doesn't matter here. You don't need to do extra work to find what is I input or VI input. This is a formula, but you can twist the formula if you master the concept of transformers. Okay, number 5. An input and output voltage of an ideal transformer is 240 and 12. If the current on the primary coil is 0.3, calculate current on secondary coil. Again, this is not given the power, but we assume that the power is the same because due to ideal transformer 100% efficiency. So power input must be equal to power output. V input I input equal to V output I output. It asks us to calculate the secondary coil current. So let's rearrange our formula. Become IO equal to VI, II, VO. VI is 240, II is 0.3, VO is 12. So if we plug in that into the calculator, we got 6 amperes. So again, our answer is correct. Number 6, a step down transformer supply 240 0.6 ampere primary coil. The voltage produced at secondary coil is 60 volt 1.92 ampere. Is this transformer ideal? So we need to calculate the efficiency. So efficiency, power input, power output over power input times 100%. So V output, I output over V input, I input, and 100%. So V output is 60, I output is 1.92, V input is 240, 0.6 times 100%, 60 times 1.92 divided by 240 times 0.6 times 100%. 80%. So this is not ideal, but this is kinda general case, common case of transformer in the field of that in the real world. That there no such thing as ideal transformer in the real world because there must be some kind of energy loss. So 80% is already good enough. Okay, but usually we need to achieve higher efficiency in order to achieve higher output power. Okay, number 7, the step down transformer. So this step down efficiency is 60%, used to convert 240 to 30. If the current primary is 1.2, calculate the current of secondary coil. So we have our formula here. V output, I output, V input, I input times 100%. So we need to calculate the secondary coil current. So we need to rearrange. So efficiency times VI divided by V naught and 100 to get the I output. So the efficiency is 60, VIII input. Input is 240, 1.2. The output is 30, 100. So if you plug in that into the calculator, divided by 30 divided by 100, 5.76 ampere. So our answer is correct. Again, that if you don't have enough confidence to rearrange the formula, then you just plug in the value first and then rearrange it later. But in this case, if you know your math, then rearrange can help you in terms of easiness of calculation for the calculator. Okay, so let's move on to the next topic, that use transformer, which is basically the application of transformer, generation and transmission of electricity. Compare the brightness of the bulb PQR. So PQR. So we have 120 to 1400 turns for the transformer. So this is step up. And then we have 2400 turns and 60 turns. So this is step down transformer. We only have 2 transformers. We need to compare the brightness. So how much? 120 to 200, 2400. How much it increased? 20 times. How much it reduced over here? 40 times reduced. So let's assume we supply to 1000 watt over here. Let's just assume not 1000 watt, 1000 volt. 1000 volt over here. Then what happened to Q? It increased 20 times, it becomes 20,000 volt over Q, and then 2000 volt reduced 40 times, 500 volt over R. So now it doesn't matter how much volt that you want to put here, this is just a very simple value that we can calculate easily in calculator that get us even numbers, but you can use any numbers you can if you want to. So based on the voltage itself, we can see that Q is the brightest, then followed by P, and then R is the dimmest. So this is the order, the decreasing order of the brightness of the cloud. So that is the use of transformer to increase or decrease the voltage. But why? Why we need to increase the voltage before it reach the national grid network NGN? Because we want to reduce power loss. So we're gonna explain about power loss later, but now just remember that we need to increase the voltage before the NGN, National Grid Network, and then we need to reduce back the voltage before it reaches the home. So number 2, determine the type of transformer used at X, Y, and Z. X, Y, and Z. So again, before it go to the NGN, National Grid Network, it must be stepped up. And then when it goes to the home or users, then it must step down. And then this must be stepped down as well because the requirement for heavy industry is different than the residential area. Okay, number 3, find the power loss in a transmission cable when 20 kilowatt is transmitted to a cable of 1.5 ohms. So before we do the calculation, I just need to explain why we need to increase the voltage to reduce power loss. So first, at power station over here, we use the concept of electromagnetic induction. We use turbine, the turbine being rotated by steam or usually steam or water for hydroelectric or wind for wind turbine, but usually steam. But how we're gonna generate steam, it depends. Most of the energy produced in our country are based on petroleum or natural gas. That means we heat the water using natural gas or petroleum, and then the water becomes steam, and the steam will rotate the turbine to produce induced current. The turbine is basically a motor, but it's not motor because we don't supply current to it. It's just the armature being rotated in magnetic field. So that's produced magnetic field flux, changes in the magnetic field flux, thus produce induced current. So we can increase the output induced current by using the Faraday's law, by increasing the rate change of the magnetic field flux by rotating faster or using stronger magnets or using smaller resistant wire by increasing the diameter of the wire. So basically that is the story for power station. Thus we use usually AC current. Why? Alternating current, because we want to step up. Because alternating current can be stepped up and stepped down using transformer. If we generate using direct current, then we cannot step up or step down. So why we need to step up? Because we want to reduce power loss by reducing current. So again, power input equal to power output. If we assume that the case is ideal, so VI equal to VO IO. So input must be the same. So for example, if we just say that this is 500 watts, then the output must be 500 watt as well. But we say that we increase voltage, that means the current gonna reduce in order to get 500 watts, in order to get a constant value. So that's the first reason. We increase the voltage. We use the step-up transformer. In order to do that, we need alternating current. So the power station must use alternating current generator. So in order to increase the voltage, it must be alternating current by using step-up transformer. Why we need to increase the voltage? Because we want to reduce the current. Why we want to reduce the current? Because we want to reduce power loss. Then this is the final answer. Power loss, the formula is I square R. So R resistance gonna be constant because we use the same wire throughout the whole network here. So we don't need to change the wire because it's costly, very costly. We just leave it as it is, the wire. So the resistance doesn't change. What we can do now, we can change the current. So if the resistance doesn't change, that means the current can be changed by decreasing the value of the current to reduce power loss. So current and power loss are directly proportional to each other. So basically I square, current square is directly proportional to power loss. So smaller current, so smaller power loss. Okay, that is the reason why we need to increase the voltage before it goes to NGN, National Grid Network. And why again we need to use AC? Because other than we need to increase the voltage, we can also decrease the voltage according to the specific needs. So heavy industry is different uses of voltage compared to light industry, compared to offices, and of course residential area is usually around 240 volts. That is the lowest voltage that can be supplied. So now let's move on to number 3. We are ready to answer our question here. Find the power loss in a transmission cable when 20 kilowatt is transmitted through a cable of 1.5 ohm. So this is power loss, this is power supply. It is different formula. Power loss is Pi square R, power supply is P equal to VI. So do not confuse. So based on the formula Pi square R, we already have the value of R, 1.5 ohm. That means we need the value of I. Where we can get that? We can get that from here. I over here. How are we gonna do that? We already given the value of the voltage 200 volts, so we just need to find the current. So I equal to P over V. The P is 20 kilowatt over 200 volts. So again, make sure that you put kilo in your calculator, which is shift 6 divided by 200 volts, become 100 amperes. So that is the first step. We need to find the current, and then from that we can calculate the power loss using the formula I squared R. I is 100 square times 1.5 ohm. So putting that into calculator, it becomes 15,000 watts per kilo. 15 kilowatts. 100 ampere, 15K. Okay, so how about a high voltage? So again, we need to calculate I, P over V. P is still the same. Now the voltage is 10 kilovolts, so the kilo can cancel out. So you don't need to plug in K in the calculator. But in case if you are very curious to know, if you are very careful, you just plug in the K. It doesn't matter. So again, 0 also can be cancelled out. Just 2 divided by 1. 2 divided by 1 is 2 ampere. So the current reduced significantly if we increase the voltage. That's the point here. Because we want to reduce power loss. We see that the power loss gonna also reduce significantly. Very, very much. So it's still the same value of resistance. 6 watt. Wow. As compared to 15K, 6 watt need this one. Definitely goes with lower current, definitely goes with higher. So we really need the step-up transformer. In order to use the step-up transformer, we need alternating current. So the concept is now linked together. So that's why this topic is very crucial because it's linked together the concept, and then it's very important in our daily life because we need electricity in our daily life. So number 4, electric power is transmitted from a power station to a town by a transmission cables with a total resistance of 50 ohm. If the power station generates 8 megawatt hours, so this is the PVI. Calculate the power loss. This is PI square R. In the cable is the power transmitted, not power, this is voltage at 8 kilovolt. Okay, so to avoid the confusion here, we just label voltage there. Again, the first step is to find the current by using the 8 megawatt, 80 kilovolt. In this case, we cannot cancel the mega in kilo, but basically mega divided by kilo, it becomes kilo. But you can just put that into the calculator. 8 mega, 8 shift 7 divided by 80 kilo, 80 shift 6 become 100 ampere. So then we can calculate the power loss. 100 ampere times 50 ohm. The power loss is 500,000 watt or 500 kilowatt. Okay, 100 and 500. So let's do at higher voltage. We can see that it's gonna reduce the current significantly. So that is the point here. We need lower current. Remember that because this is very important question that usually asked in paper 1. Become 20 ampere, then the power loss is gonna be reduced significantly as well. Okay, you almost cannot believe it. 20,000 watt. Again, as compared to 500, we like lesser value. So 20 ohm at 20 ampere and 20 K. Okay, that's all for today. I hope that you understand the concept of transformer, how to explain the working principle of transformer, how to use the calculation, the ratio to find the output voltage or output current or input voltage, input current, efficiency. If the transformer is idle, you don't need the efficiency formula. You just use direct VI equal to VO. If the transformer is not ideal, then you can use the efficiency formula. But basically, you can just use the efficiency formula for everything for transformer. If the transformer is ideal, you just replace the efficiency by 100%. As simple as that, and then you can get back the same formula as the ideal transformer formula. And then you must understand why we need alternating current at power station. Why we need to produce alternating current? Because alternating current can be stepped up and stepped down using transformer. That is the reason why alternating current is important. Why we need to step up or step down? Because we want to increase voltage. Why we need increase voltage? Because we want to reduce current. Why we want to reduce current? Because we want to reduce power loss. That's the end game over here, because we need to reduce power loss. So the power that we get at home is sufficient to turn on all the electrical appliances. So all the concepts are linked together, and I hope that you understand deeply about this concept, because transformer is not that hard as compared to the induction and the motor effect that we already learned previously. This is very simple concept. You must understand it fully, and it also usually come out in paper 1 as well. So hopefully that you understand all the concept and practice as much as possible. So do some of the paper 1 question and see that a lot of the question regarding about the power loss, about why we need to increase the voltage for electrical transmission usually come up frequently. So hopefully you study very well and hope to see you soon. Please watch other videos as well if you have some problems in other areas. So thank you. See you soon.